Okay, today we're going to be looking at the vector equation of the line. So you're very familiar with the equation y equals mx plus c as the general equation of a line in 2 dimensions. Now we can rearrange this as being y plus mx equals c, and we can put another we can further generalize this by calling it ax plus bx equals c. And you've seen equations like that for a straight line. Now we can extend this into a three-dimensional space and have a three-dimensional equation for a line in three-dimensional space of ax plus by plus cz equals some constant d. Now we're going to look at the equation of a vector line, and we can do this in both 2 and 3 dimensional space. So let's think of a situation where we have a point A, which is the coordinates A1, A2, A3, and we have a direction vector B, B1, B2, B3, and it is parallel to the line. So we have this line here, we have point A, and we have our origin. So we've got a position vector OA here, and now we have on our line some point R with coordinates x, y, and z. And we've got this line vector here. And we've got a vector OR up here. Now, R is a point on the line, so that OR can be represented by, so this is OR, but we can also represent OR by OA plus AR. Plus AR, so let's do a wee vector. It's there. Now we know this vector OA, and we've also got the vector parallel. This is meant to be parallel. This is vector B. We know vector OA, and we don't know this specifically what this vector is, but this vector, this point R, could be slid along anywhere along this line. But we know that B, vector B, is parallel to this line, so we can rewrite this as where t is some constant that we multiply by b, because these two vectors are parallel. We can multiply b by a constant to make it the same as AR. Now we're going to see that we are going to be using different parameters in this section to multiply vectors with, and they'll often be used. Mu and lambda are two most common Greek letters that we use as to define our parameters. So the general case of this would be vector R is equal to A plus TB, where B is that parallel vector. Now we can have another situation where we have a straight line and we have point A, and this time, so that's going to be A1, A2, A3, and we can have point C, C1, C2, C3, and again we have our point R. So X, Y, Z. and there's a wee arrow. So down here is our origin, and here is our vector r. So this is very similar to before, but this time our OR is going to be OA plus, now this point C, AC can be slid along here till it gets to R. So we can change the length of this vector AC to get to R by multiplying it by another parameter, which we'll call T. So our general version of this is R equals A plus, now if you think about what AC stands, there's our T, vector AC is C minus A, if we had some point up to C, some vector to C there. This would be the general version of this. So in general, what we have is a general point on line is equal to the position of a known point, in this case A, plus some way along a known direction. So this is our point, either our AC, we know it's going along this direction, it'll meet R if we multiply, if our T is correct, and this one similarly, we've got this parallel vector B. So this is a general rule for the line equation of vector. Now we can deal with this in parametric form. So we've got our R, it's X, Y, Z. So R is vector R is going to be X, Y, Z, or it's equal to Xi plus Yj plus Zk. So we have our equation R equals A plus TB, and we've got our X, Y, Z, and here we have our coordinates A1, A2, A3 plus our T, and then we've got our B1, B2, B3. Or we can write that as Xi plus Yj plus Zk equals A1i plus A2j plus A3k plus T, open bracket, and the same with our B vector, Bi plus B2j, actually that's meant to be B1, and there's our I, plus B3k. And so we can rearrange both of these as, we've got X, Y. Actually, we'll put that up there actually. So for this one, we've got our X, Y, Z equals A1 plus TB1, A2 plus TB2, A3 plus TB3. Or with this, we can then rearrange this as AI plus Yj plus Zk is going to be tidying this up, A1 plus TB1 I plus A2 plus TB2J plus A3 plus TB3K. And you can then compare coordinates. So you'd have our X is this, Y is this, Z is that. So these three equations are known as the parametric equations of the line. Okay, let's work through some examples of this so we can see it in practice. So we've got a line that passes through with position vector (3i minus 2j plus 4k) and is parallel to vector I minus j plus k. And we want to find, firstly, the vector equation of the line and the parametric equation of the line. So we're going to have t as our parameter, so our general point is going to be r. Our known point is going to be our 3i minus 2j plus 4k, and our known direction is I minus j plus k. So we have our general rule is going to be R equals A plus TB. So R is our general point, and A is going to be 3 minus 2, 4, plus T is going to be 1 minus 1, 1, and that's our equation of the line. So you can write, so we've written as this the column vector, and now we want to find the parametric. So R is just x, y, z. So we'll have our x, y, z, and then we can just do we can do 3, this is just 1t, so 3 plus t, then minus 2 minus t, then 4 add t. Or that can be written as xi plus y j plus z k equals, and then we just pull out our x, y's and z's, 3 plus, t I plus minus 2 minus 1 j plus 4 plus t k, and then comparing our components, x is going to be 3 plus t, y is going to be minus 2 minus 1, and z is equal to 4, what's meant to be a t, 4 plus t. Let's do another one. So the position vector and points A and B are given by A equals 3I plus 2, it's not a very good plus, it looks like a 2, plus 2j minus 7k. And B is given by I minus 4j plus 8k. And so we want the vector, so want to write, what am I trying to do? I'm not writing very well. Write down vector AB and find the equation of the line AB. So vector AB is going to be, remember this is going to be like if we had, there's our origin, here's A, vector A, here's vector B, this is B, this is A, and we want AB. So to go from AB, we need to go minus A plus B. So there's our B minus A. So our B is I minus 4j plus 8k minus, make sure you put in brackets so you carry them negative through, plus 2j minus 7k. So it's going to be minus 2i minus 4 minus 2 is minus 6j plus 8 minus 7 is going to be plus 15k. Okay, now we want to find the line equation of the curve. So we know our general point is R. Our known point is going to be A, so it's 3I plus 4 oh, it's meant to be a 4. Is it meant to be a 4? No, it's a 2. Ah, the book has an error, so this is 2. So this is 2j minus 7k. So we take the point A as our known point, and AB, so this is our known point, and this AB is going to be our known direction. Is going to be AB, which is minus 2I minus 6j plus 15k. So we know that R is going to be equal to A plus T A B. So R is going to be 3I plus 2j minus 7k plus T, and it's minus 2I minus 6j plus 15k. And that is our equation of the vector line. Now, when we did the dot product, we found that the angle we found a way of finding the angle between two vectors, and we can use that to state that the angle between two lines is the angle between the two direction vectors of the lines. So we're thinking about the direction vectors. So let us do a question. The vector equation of line 1 is equal to r 3I plus j minus k plus lambda I minus hi plus 5. Okay, it's meant to be a 5 there. There we go. Now, line L2 is parallel to L1 and passes through point A 0, 2, 5. Write down the vector equation of the line L2. So we're going to use mu as the parameter. And the general point R is still equal to known as the known point plus the known direction vector. So our known point is this point here, point and point A, so it's going to be 2j plus 5k. Now the direction vector is going to be, because line L1 and L2 are both parallel, the direction vector that we're going to use for line 2 is the same as the one we're going to use that's been used in line 1, but we'll just change the parameter. So the known direction is I minus 8j plus, was it minus? Plus, there's a plus. It's really badly written. 5k. So our line 2 is going to be 2j plus 5k plus mu I minus 8j plus 5k. So now that we have our equation for line 2, the next thing we want to find is the angle between line 1 and this line R, so it's not this one but a different line, Ri plus 3j minus 2k plus parameter mu 5I minus j plus 2k. Okay, so when we're going to have we're taking the scalar product of the directional vectors D1 and D2. Because remember, the angle between two lines is the angle between the two direction vectors. So D1, so line 1 is this, so D1 is this part here. So I minus HI plus 5K, and D2 is this part here. So 5I minus J plus 2K. So the magnitude of D1 is, oh, actually no, we want to do the dot product first. So we've got D1 dot D2, and again that's going to be 1 times 5 plus minus 8 times minus 1 plus 5 times 2, and that gives us 23. And then we're going to take the magnitude of D1, so that's 1 squared plus 8 squared plus 5 squared, which is going to be 3 root 10, and then the magnitude of D2, which is going to be 5 squared plus 1 squared plus 2 squared, which comes out root 30. And now we know that D1, D2, the directional vectors multiplied together are equal to the magnitude of D1, the magnitude of D2 times cos theta. So that gives us, we've got 23 is equal to 3 root 10 times root 30 cos theta. So so theta, just do theta, is equal to 63.7 degrees. So I hope that helps.